Hey everyone, this is your web dev sumos, and today we will solve 198, which is house robber. Okay, so enough of that. So basically, I'm going through the questions again because when I first saw them, or twice saw them, or thrice saw them, I didn't really get how Leetcode, how everyone is coming, how they are able to come to the solution where they are forming tabulated form, or how they go even about thinking recursively to solve these questions. So, as the code says, if you keep trying once, twice, thrice, you'll try to see the pattern, you'll try to see what the question was really saying, and it's just me trying to get comfortable with these sort of questions, the DP especially, and trying to see what exactly the question is trying to say. So far today I've done the climbing stairs and min cost climbing stairs. So I didn't really make a video on climbing stairs, but I did happen to make minimum cost climbing stairs, which uses the similar approach for solving the climbing stairs as well. But yeah, anyways, you can always go to the Leetcode videos, and those are the best. And I'm also learning from him and trying uh, trying to learn as much as possible here. So without wasting any time, we'll get started. You are a professional robber planning to rob house along a street. Each house has a certain amount of money stashed. The only constraint shopping you. Wait a minute. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken onto the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so we cannot rob adjacent houses. That's that, and we want to take as a good amount of money from each house. Like the profit should be maximum when when the robber is doing such a risky job. He does want to make good amount of money, and yeah, we'll try to help him out. So 1231 is given to us. So I'm just thinking, how can I traverse it? Like, can I go from the 0th house, or I can start from the last house? How can I go about solving this question? So, okay. So the scenario is we cannot rob two adjacent houses, right? Um, and what what I'm planning to do is that I will do a knapsack approach for this one, right? So if I rob house first, I'll probably start from the first house, because that's what my intuition says, and I'll send my dummy nodes to find out if robbing that house is going to be profitable or not. What I'll do is take first house, rob it, then naturally we cannot take the next house to it, so we have to take different house. And on the other end, what I want to do is not rob. I don't want to rob house for the first house. I want to rob the second house. Okay, yeah, I want to rob the second house. So I want to see, if I start from the second house, what will I get from that index. So my two pointers, my two starting point would be either the 0th house or the first house. That's what I'm thinking. That's where my search will begin. And then then what I want to do is, yeah, what I want to do is calculate the maximum amount that I can calculate when I get. So what should be my base case when I'm doing such? Sending my pods to search all the houses and all the combinations. So my pods should stop at um, where the index, where there are no more houses to explore. Yeah, basically when my I becomes greater than the number of houses, basically the index that I'm currently on, um, if it is greater than the number of houses that were given to me to rob, then I should probably stop, right? I cannot go further than that. So that should be my base case, I'm thinking. And okay, so why don't we take the Miro board into the action and see how it goes. I I'm sure if we go through, if we try run this and see what is the possibilities to rob the houses, then we can surely find a good house, good amount of houses to rob and sleep happily without getting caught. Right? That's the dream. Uh, House robber. And given the unemployment situation right now, many people would love to do this. Just kidding. Some random jokes. Okay. Uh, yeah. So I didn't actually get the number of houses that were given to us. So the number of houses that are given to us is 1, 2, 3, 1 here. So I see 1, 2, 3, 1, and the let's call them houses. So what I'll do is I'll take the first house. Okay, and if I need to start from the first house, right? The first house. Yeah, I need to basically start from the first house, and so in so I'm just thinking like how will I be going uh, go about writing that recursive relation. I'm just thinking about that. So my idea is to start from the 0th index, right? And I just want to get to the last house somehow. So what I'll do is um, I'll take one. Um, Basically, we want to have maximum profit at the end of the day, isn't it? That's what we want. So why don't I do this? I'll start from the 0. I'll rob house 0. So my profit at that point would be profit plus um, the cost, let's say cost of robbing house I, right? So if I rob the first house, then naturally I cannot rob the second house, right? The second house. So um, the index that I must be sending next should be I plus 2 instead of this, and I should be also doing the same. So I won't rob this house at this time, so I'll keep the profit as is, and I'll say I won't rob. I don't get good feeling of one bot will say that I get good feeling robbing the house, first house, and the other bot will say I don't really feel good robbing the first house. So we'll just increment our pointer and see and try out our luck there. So initially our profit would be zero, right? So that's where we'll start our search from, and then grow upon that. Yeah, and once we finally reach the end, we our index kind of max out on us on the houses that we have. Then whatever the profit that we were sending upstairs, we can actually um, take that profit and store it in the actual variable that we want to send out later as our answer, because that will be probably observing which house I can rob and make sure and then return that. So that's what I'm thinking. So let's dry run this for now. That's what I'm thinking the recurrence relation will be. But let's say, and let's give them these guys deserve some indexing, so let's give them indexes. And then what we'll do is we'll start with index 0, so we'll be sending 0, just 0, and we'll say rob this house. So this relation we have, right? So rob this house, and the profit would be 1 plus 0, and that's what we'll send. So profit would be this, and will be, so what should I write here? I'm just thinking, let me think. So I'll go to index 1, and on index 1 our profit would be 0 plus 1, so value is 1, right? That's why I'm writing 1. Oh, sorry, my bad. So if we start on index, if we send out index 0, then it will branch out. So either it will branch out to I plus 2, because we robbed the 0th house. Sorry, pardon my explanation, but yeah, 0 means we robbed the first house, and I plus 1 means we didn't really consider robbing the first house. And here the profit would be, at this stage, I'll just write the profit that we are continuing from robbing house 1. The value was 1 here, so our profit would be 0 plus 1, and our profit at here will be 0. So from here we'll go on to the index 2, and from here we'll go on to the index 1. So again we'll see from index 2 we say that okay, let's rob this guy and see what happens. So my profit is actually going to be it was 1, so 3 plus 1 would be 4. At this stage my profit would be 4, and I will be incrementing 2 spaces, right? So I'll be going on index 4 from here. Oh no, wait a minute. So at this stage I've exceeded the number of houses that I can traverse, so basically 4. So I don't have anything. So here at this point I can store this store the 4 that we have got here into the max profit. I'll say it's so let's not write it here in bottom. Let's write the max profit here. max profit now is 4. Okay, so what we can do next is that we can explore other options as well. So here we said that we'll rob house on the index 2, but here we say that let's not rob house 2, and we just increment we just keep the profit as 1 and go on to the index 3, right, plus 1. That means 2 plus 1 is 3. So we go on index 3. We see that we decide either to rob it or not to rob it. So if we rob it, then our profit uh, would be 2, and our next index would be 5. And here we can simply check if check with our maximum, but our maximum is 4, so we won't update it, right? and and here where and if we don't consider robbing it, so it's 4 and 1, so we won't consider this either, right? um, and let's go to house at index 1. So house at index 1 will decide to rob it or not rob it. So if we decide to rob it, then 0 plus 2 will be 2, and we'll go to index 3. From 1 we'll go to index 3. um, so here we'll decide to rob it or not to rob it. So at index 3 I will add 3 plus 2 is 5, and I will jump on to index 5. So at this stage I'll compare my profit with the profit stored. Oh no, so oh yes, now I can see that my profit has increased, so I will get rid of the earlier profit and I'll store the current profit that I have. And then I'll keep the search on in the hope that I'll get a good house to rob. Then I decided not to rob the third house as well. So the profit 2 will be as is, and I'll continue to 4. But at this stage I've reached the end, like this guy, and it's not looking good. 2 is not good at all, right? So if we compare it, we will compare it and not update it, and just keep exploring the other branches. So how about we decided not to rob index 1, right? So here we will go to index 2 with uh, with with 0 profit, and decide either to rob the house or not rob the house. If we rob the house, then our profit would be 3, and we'll go to index 4, which is end. And this does not look good. The profit that we have when we reach exhaust all the houses, the profit does not look good that we have when we traverse this path. So we won't update anything. And later on if we go to we decided not to rob this house, then the value would be 0, and we'll go on to 3. Then we decide to rob this house, which will be 1, 0 plus 1, and not to rob the house, well, it will be still 0. And here we'll reach 5, and here we'll reach 4, which is n, which is and similarly this doesn't look good, this doesn't look good. Okay, so if I observe here, I guess there are some elements that are repeating, and I don't like the feel of it, but the value that they have are kind of similar, not similar exactly, because um, Yeah, they are all different. So at the end, when we are done traveling every possible combination, uh, our our profit would be this guy. um, yeah, that will be our profit, and we'll be returning that. So this is a brute force approach. This is a very brute force approach, I would say, and uh, let, uh, let's try to implement it. And the time complexity of this would be, we are exploring each and every node, and we are making two decisions at every index. So it will be 2 raised to n, where n is the length of the houses, which is an exponential term, and which is not a great time complexity, but it will guarantee a result if yeah. So what we need to do here is, we want a rob helper which will run our bots, um, for checking the entire thing, and will start rob helper from 0th index. Yeah, that's what will start, and we will also need to keep a profit, right, for the traveling. So let's call it, I don't want to make the variables a variable name longer, so h, let's call it h, and let's call it profit. Okay, and let's call it max profit is equal to, so nums would be, let's call it -1. And once we are done with this guy, then we'll be returning profit, right? Okay, so yeah, let's do this. And if our house index, let's call it h index, if our house index is greater than equal to nums dot length, then I guess whatever the profit is, math dot max profit, and max profit is equal to max profit is equal to this guy, right? That's what we'll do, and we will basically return out of this guy. Okay, so yeah, that's what we'll do. and and let's say if yeah, what I need to do is, I need to call rob helper if I decide to rob house 1, like the house that we are currently on. Then all I have to do is I have to increment my index and add current house that we are on, cause sorry, nums of h index. Yeah, so that means I robbed this house, and the next one would be, I didn't I don't want to rob the current house, and I'll leave it as is, and the profit as is. So yeah, we'll go to the next one, and let's see if this works. So yeah, it does work, but it will start failing when our nums dot length will eventually grow out. And see, if I submit this is going to exceed the time limit, and yeah, that's not a good sign. So see, till 55 it ran, but but the thing was, it like till 54th test case it ran, but on 55th it stopped. And the one more mistake that I did today in my pram interview was, I I'm recursively going to the point where I'm storing my max profit, um, into the max profit. But the thing is, um, for all that computation I'm doing, there might be an overlap that I want to avoid in future computation. So all I need to do is, when I reach the last index, I need to be sending that profit back to um, the um, whatever the profit that I made from that particular index while traveling from that particular index. I guess I need to send that back, right? And what I need to do is return math.max of both the guys. Like I will be going to trying to rob both of them, right? So whatever the max would be there, I need to send that back. Okay, I need to send that back. I will just comment this out and comment this out as well, and see if I can ju- just return this rob helper. Yeah, so this does work. So whatever the profit I'm making at that index, I'm actually returning it back. Okay, and finally I can return the max profit. Okay, so let's go on to the Miro board and let's see it one more time. What are we actually doing? So the last time we were keeping the track of the max profit using this variable, right? So now what we'll do is we'll try to send the max profit upstairs, and whichever is the max will keep on sending that upstairs. Okay, so let's do it here from 2 and 1. Okay, from 5 and 4. So whatever, whichever is max, is 2 max or 1 max. 2 is max, right? So we'll send 2 upstairs. We'll send 2 upstairs, so 2 will be here, then 2 will be compared with 4 and 2, so 4 is maximum, so we'll send 4 upstairs, so 4 will be here. And then from these two guys, 5 is greater, so I'll send 5. And from this guy, so 1 is greater, I'll send 1. I'll send 1 upstairs, and from this guy, 3 is greater, so 3 and 1 will be compared. 3 will be sent upstairs, so 3 and 5 will be compared. 5 will be sent upstairs, and 5 and 4 will be compared, um, and then 5 will be sent. Okay, so that's that. Yep. So is there a point, um, is there any point where we can identify what would be the max value I can get out of from particular index? Yes, we can definitely figure that out, right? Like if we are on particular index, we can definitely figure out by doing this computation what would be the max value at that particular index, right? So what I'm trying to see is that, let me so there is a lot of mess here, it's difficult to navigate actually. um, so I'm just looking at 3. So 3 did give me a max of 2. So if I eventually see a index 3, then yeah, um, do I want to explore it further? Because if you see, if I come here, 2 is there, then I come here, 2 is there, then I come here, 3 is there, this sorry, my bad. So I'll just use a different color. I come here, then I come here, then 4 I found, then I come here, then this guy, so 5 I found, 5 is greater, I send 2 2. Then for 3, um, so if where can I draw a cache? So I'll just so even if I am using a cache for all the indexes, right? um, Memo, I'll, I'll use a memo. So my houses are 0 1 2 3 4. Okay, so I won't write them out now, but yeah. So I'll come here, and now 2 and 1 from 3. if I if I see for my index what would be a value. So what I was thinking is, whatever the value of 3 would be, like what I can 3 get a max of 3 from. So I'll store that value, um, which is 2. So on index 3 I can get a max of 2. So that's what I can get. And for index 2 I can get max of 4 from this guy as I'm going up. And okay, so I've 4 here. So if I visit index 1, so I have not seen it any further, right? So what I do is, I I decide to rob that house and decide to go here. Okay, okay. What I want to do is, whatever the profit that I've accumulated, so I've cashed 3 from robbing house 3. I'll always get 2, right? If I decide to rob house 3. So all I want to take care of is, whatever I rob, keep whatever that I've robbed so far. uh, I have to get, if I have seen the house in the if I have kept the if I have stored the house robbery in my memo, then I can take the because I know now at that particular index I can get this much value, so 2 I'll get. But when I was robbing house 1, then my value was 2, and I will basically add that to my index, right? Yeah. So how did it become? I guess the answer is 4 for that one. I guess I have yeah, the answer is 4, so my bad. It's not 5 here, it's actually 4. So 3, so we calculated 2, and then 3 gives us 2. Yeah. And yeah, so we will basically be having 4 here. Yeah, we'll having 4, not 5. I'm really sorry, I apologize for that. Yeah. So yeah, that basically solves, oops, sorry, excitement excitement to finally understand what am I doing. So yeah, what we can do is, whenever we find a So this will definitely um, give us a max house, right? um, Let me run this for the sake of it, like that's how we are progressing, right? So this is definitely going to give me, we'll have a memo. We won't have this. Let memo is equal to an object. So I'm having this object. So what my memo will do, memo of that index that we are currently exploring, house index, sorry, yeah. So for that house index, we'll store whatever the maximum profit that we can accumulate, and we will return that memo index, further h index. But what if we identified that index again? If in memo, if we encounter that we are about to explore the same h index, we want to save our bot work. So what we do is, bot will straight away check if this house is explored, and get the maximum value from it. Memo of h index, he'll get the maximum value and he'll just add the current profit added so far, so that so that uh, so that whatever the calculations that we have done, or whatever the robbery we have done so far, we can add it to the current house, because this memo knows whatever the max value of that particular house was. So this memo knows that. So uh, yeah, yeah, that's all I can say about this. I guess this will definitely help us. uh, but wait a minute, am I missing out something? Memo, if h index is in memo, then I am simply sending that. Okay, so why is this wrong? Instead of, do I just need to, okay, sorry, do I need to check this before this one? No. Then what's the issue? Really? I thought, yeah, that's what I thought. Like this shouldn't be working. We have to add the profit that uh, we have got so far. So where did I got this wrong? Where did I? Where might have I might have got it wrong. I am not sure. So time limit exited, everything. Let me see this. So what I'm doing is I'm returning 0 from this guy. Okay, I'm returning 0 when I reach the length, and okay, so but if I want to send the profit, what's the problem in that? Like, I want to calculate calculate the profit as and when I go upstairs. So will that cause a problem? Mm, oh, okay. Okay, let me check out the editorial because I've been doing this for last 40 minutes and okay. So they did um let me do the solutions. So yeah, that's it's the same thing that they are doing here. Okay. So yeah, I should have done the same thing rather than I should have done the minimum cost of climbing stairs. I should have applied the same approach for doing this one as well. Yeah. Okay. Looks like we were not able to do it as we were expecting it to be, but yeah. So how did my first approach worked and not the second one? So me storing the profit at every end is that okay. Okay, so yeah, I guess there might be a chance. There might be a chance where yeah, I was looking at the board. Yeah, so this three is stored. So the maximum it got was two, and when we come here, the maximum this guy was able to accumulate was 1 and 0. So I guess for that matter of fact this won't be working, but I should have stuck to how did I not use the minimum cost of climbing stairs approach. Okay. Okay, got it. So what I'll do is I'll stop the stream because we didn't go anywhere from this. But yeah, in the next stream I'll definitely try to uh, go about this question in a better way. But good practice, no worries. Look at the upvote for this question. That's just insane. I'll also add one. Cool. Thank you so much, guys, for watching. Hopefully, we can get better at this coding and crack the interview soon. Cool. Thank you so much. Bye bye. It's sad you're not able to code this out, but